This conference will now be recorded.
Hi everyone, good morning.
Good morning, sir.
Good morning. Okay, right. So, guys, in today's session, I want to take a use case and the implementation of use case I want to show you along with GitHub and Git. Okay, GitHub and Git. So GitHub, I don't discuss a deep details or a elaborated discussion. Okay, I don't want to do elaborated discussion on these things, but at least some introduction I will give you, and then I will show you how to use this GitHub and Git in our real time. I mean, when we are working in a project, how we utilize this tool and what exactly the use of this tool and how it is part of our daily life for any developer, for any technical person. It becomes a part irrespective of technology. Okay, so for that reason we must learn how to utilize GitHub and Git along with our SOA development. Okay, so for basic understanding, GitHub is a server. It's a cloud server. I mean, it's a cloud server, or you can say remote server. Okay, it's a remote server, or you can say cloud server. Okay, so you can access this GitHub server from any location in this world. If you have internet, you can access this GitHub server. So GitHub is Git is an organization. They are providing this GitHub server. Okay, for everyone. It's not restricted to limited people. It's for everyone. Anyone can access it. I mean, um, we have two options in GitHub. You can create the repository. GitHub is a kind of repository, right? It stores the files, it stores our content, it stores our code. Okay, it stores our whatever the content is, it can store, and it can allow us to access it from anywhere in this world. Of course, it has the versioning capability. You can store the content in versions format. Okay, or we can say revisions, either version or revision ID. Okay, so this is a repository. You can store whatever content you want in versions or revision format. Okay, and of course, I will show you. I mean, what are these versions? How we create versions? Other stuff we will discuss one by one. Okay, so anyway, GitHub is allowing, Git organization is allowing everybody to utilize this GitHub. Of course, this GitHub has free version and paid version, which is a premium version. In premium version, we can create private repositories, but in free version, we can create only public repositories. I mean, if I create a repository as a free version, that can be accessible by anybody in this world. Okay, I cannot restrict it. I can i can uh, I have to give the access to anybody. It's a public repository. But of course, if I want to go to private repository, yeah, it is also possible, but I need to go for paid service, not the free one. Okay. Mm, okay, now Git. Now let's see Git. Git is a command line utility. Okay, command line utility or command line interface. You can say command line interface. So guys, this is a local setup in a developer's machine. Suppose this machine, whatever the laptop I'm using now, I'm a developer and this is my machine. Within my machine, I can install GIT, Git command line interface. Okay, that looks something this way. Okay, I already installed it. I'm just showing you how it looks like. It's like a command prompt. It's like a command prompt. Guys, here I changed the font, I changed the font color and the background color, but ideally this looks like a This looks like a, a simple Windows command prompt, not more than that. Okay. Any questions? But we need to install a small setup file. I will show you what is the file we need to install and how to set up that. Okay, right. So there are two tools we have to use, GitHub and Git. GitHub is a central repository. Git is a local installation. Git is a local installation. Okay, so both will maintain the repository only. Okay, GitHub, we can create a repository under this GitHub. What happened? Okay, this contains repository. Repository, and this guy also contains repository, but this is local copy. Okay, of course here the repository, when I said it is private or public, private or public. We use public repository only, no need to go for a paid service, at least for learning purpose. Not only learning, there are many people using the GitHub repository as a public component, and they are allowing public to part of their development. Okay, of course, but even though it is public, no one can tamper that. Okay, whenever it is public, somebody can try to tamper it, right? So there is a process we follow. Due to that process, what we can do is we cannot tamper that repository. Okay, we'll learn all this stuff anyway. So first, what we need to do, we need the GitHub account. We need the GitHub account. It's very simple. You just go to Google and you create search for GitHub. Search for GitHub. This is the URL you need to use. You can use this URL. This is the GitHub repository URL. You need to do a sign in. Sign in. You know, right? What I mean by sign in. Sign in means you need to create an account. You can use your Gmail account, guys. It's normal sign in. We can use any email ID. So for our practice purpose, you can use Gmail ID. Okay. So once you created this account, you can see this one. I already logged in. Let me sign out. Let me sign out. Okay, what you can do, if you have an account, you can go for sign in. If you don't have an account, you can go for sign up. So first time who want to create the account, you can go to this option. Okay, enter your email ID. You can give whatever email ID you want. Let me use my other email ID. No, already taken. Okay. Oh, sorry. I already have an account, so it is not allowing me my email IDs. I will do sign in. Okay, but you guys must do creation of an account. You can create an account. You can create an account and then continue. If it is this with this email ID, I already have an account. Okay, so it is not allowing me. So, but you can enter a new email ID. You can create the account. It will guide you. Okay, let me do a sign in instead of new account. I'm just doing a sign in because I already have an account. Okay, so this is how it looks like. I will show you how to create the repository. See, this is the option to create the repository. I will tell you what to do and how to do. And then what you need to do, you need to install. You need to install Git application. Git application in your machine. For that, go to Google, download Git for Windows, download Git. If you click on this, immediately it will navigate to a Git download page. Okay, so according to your operating system, whether it is Mac OS, Windows OS, or Linux OS, accordingly, you can download the Git utility. Suppose if I say Windows, it will show me the Windows options. Okay, so I want to go for standard edition. Standard edition 64-bit for Windows setup. If you just click on it, it will download the setup file. Okay, once you download the setup file, just double click on the setup file. It will start an installation wizard. Don't do any modification. Simply go next, 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 and finish. That's it. It's very simple installation. Okay, we just need to double click on this one and then complete the installation process. Any questions? So once your installation completed, how you can confirm whether the Git installation completed or not? Simply right click on your screen and you can see there is something called Git bash, Git GUI. Okay, if you see these options, that means Git command line interface installed in your machine. Are we good? Okay, so once it is done, we need to do some some configuration. Will show you when I started using this Git. Okay, right. So how exactly we use this? What is the purpose of it? How we manage it? Okay, so guys, Git is a distribution tool and version controlling tool. It's a version controlling tool. Not only Git, there are many other tools available in market, but Git is most popular and widely used today in IT industry. Okay, when multiple people working in the same project, multiple developers working in the same project on same code base, Git is the best option to utilize and execute your project. Okay, I will tell you what this repository contains. So whenever we are talking about a Git repository, whether in Git or in GitHub, whether in Git or in GitHub, Git is a local setup, GitHub is the central setup. Okay, so let me talk about one component first. Let's say I have a Git repository. I have a Git repository. Uh, in Git repository, whatever the code we have, whatever the code we are doing the development, we will keep the code into this Git repository. Okay, let me give you some diagrammatical presentation. Let's assume this is my Git repository. Okay, this Git repository contains branches. Git repository. Okay, this guy contains branches. So branch is a copy of repository. I mean, this guy, let's assume here I have some code. Here I have some code. Okay. No, I need to, this diagram is not enough. Let me expand it. Okay, let's say if we have a Git repository, this guy contains a concept called branches. Okay, so generally our branch starts with a master branch. Okay, it's a root branch or the production branch, we can say. I will tell you why I'm saying this as production. Master, production branch. Why it is called as production branch, I will tell you. Let's assume, guys, what happened. This guy contains some code. This branch, this is called a branch, master branch. This master branch contains some code. Okay, let's assume our application. Let's assume this is our code. SOA application contains arithmetic service, hello world, and project one. This guy contains 3 services. This is our code. Now this everything is available in master branch. Now what I want to do is I want to develop one more service. So in that case, what we do, I will create a feature branch. Okay, this is called feature branch. I can give any name. Feature branch name is user defined. So, but master branch name, all companies will use the prod branch as master branch. Okay. So, but I created a feature branch from this master branch. Guys, this is a kind of copy of master branch. whatever the current state of master branch, I'm creating a copy of it. It's a feature branch. Okay, in the feature branch, what I will do, what we do is we will have existing code plus we do new development, whatever. I mean, we discussed it, right? We want to develop a new service. We want to develop a new service. I want to do new development. Both will be at the same place. I mean, existing code, on top of the existing code, I will add some new code. So this is what a feature branch is called as. A feature branch contains existing code, whatever master contains. So from master, we created a feature branch. From master, we created a feature branch. In this feature branch, we enhanced it with new development. Once the development completed, then what we do, once the development completed and you think everything is good, service is good, there are no errors, everything is working as expected, then what we can do, we will merge this code again back to master. We will merge this code back to master. Okay, the final goal, whatever the code development we did, whatever the new enhancement we implemented, whatever the new feature we implemented, finally that goes to production and it becomes existing code. So see, understand the formula here. Existing code is equal to existing code plus new code. This is the formula. Observe the formula. So from how we did, we have a master branch which has some code. From master branch, we created the feature branch. In the feature branch, what we did, sir? We have an existing code plus we did the new development. The combination, if it is working perfectly, and then we move the code to again back to master branch. From master branch, we deploy the code into our production SOA server. If it is SOA code, we deploy it into SOA server. Java code deployed into Java server. It's not just for SOA. This Git concept is not just meant for SOA. This concept is for any technology. When a team of people working together, they will use the Git repositories. Any questions till now? Any questions? Please speak out.
No, sir.
No question?
No, sir.
Okay, good. So how it is helpful when team of people works together. Okay, so guys, this is Git repository. I said this is Git repository, right? So Git repository is in developer's machine. It is in developer's machine. Okay, so then what we do, this Git repository, we will have a local copy. It's in my machine. It's in my machine. Okay, there is a central repository which is nothing but GitHub. Okay, let me do this. Let me cut the image. See, this is GitHub. It's a central repository which is accessible to multiple people. GitHub, okay, it is accessible to multiple people. So what we do when we want to have our local, I mean, this is a Git repository, developer's machine. This is dev machine. Okay, and this is a GitHub, which is a server machine. This is a server machine. Observe, both look same. Okay, server machine. Both will have the same setup. So what we need to do, we need to perform something called clone. We need to perform something called clone. Then you will get the copy. Clone. And then once, see what will happen. GitHub is a central repository. It's a server machine. Here we have the repository setup where you can have master branches, you can create a feature branch, existing code plus new development, and then you can merge it. You can merge it to master. This process is called merge process. Merge process. Okay. So when you perform a clone on your server repository, GitHub repository, when you perform a clone, you will get the same server repository into your local machine. So this is your Git repository. It will be, the entire repository will be downloaded into your machine with the same infrastructure. You will have all the branches. Server, let's assume server have 100 branches. In your local machine also, you will get 100 branches. Any questions? Okay, so here the concept is multiple developers can access this repository with a clone. Any number of developers can access this repository with a clone. You got my points? Repository will remain same. Central hub, GitHub will remain same, but from this GitHub, any number of people, any number of developers can perform a Git clone and they can do the development. They can do the development. Okay, same repository they can access, they can do the development. So this operation we are calling as clone. You have to do a clone. Okay, you have to do a clone. Once your development is over, whatever changes you are doing in Git repository, not GitHub, in your Git repository, if you are doing some code changes, I mean, you are working on a code, you are working on a code change, you created a new feature branch, something you did, okay, and then you merged into your local master. See, local feature branch, this is local feature branch for a developer, this is local master branch for a developer. So once he completed his changes, code changes, he need to go back, he need to push everything into the server. You need to push everything into the server. Every developer, whatever code changes he did, finally, he need to push every of your code change. Whatever change he did, he need to push it into server. This process, we are calling it as push process. Okay, we have a single central repository. Every developer can access the single central repository, which is nothing but GitHub, Okay, so they can do their code changes and they can publish, they can push the code changes finally into central repository, which is a common place to everybody. Every developer can access the GitHub central repository. Any questions till now? You understand the difference between GitHub and Git repository? GitHub is a central repository. Git is your local copy. Any questions?
No, sir. Clear.
Clear. Okay, done. So let's do this. I just gave you very high level introduction, guys. There are so many commands we do. Not only I discussed about only few, right? Creating a branch. Okay. Clone central repository to local copy. Push the local copy to central repository. Something called merge. So I discussed a few keywords. These are not enough. There are so many other commands and keywords we use in the process. We'll see them. Okay. Right. So now come to the use case. Let me open a new page. So what I want to do, I want to discuss about one use case, guys. In that use case, we want to use this Git as well, along with the SOA development. So what I want to do, a simple use case I want to implement. I want to implement three SOA services. Okay. And I want to establish an integration between these three SOA services, all three SOA web services. Okay. This is, I will name it as order processing system, and this one I will name it as card validation system. Okay, this one I will name it as billing system. I will tell you what each program will do. Okay, And guys, here I want to create this service as synchronous web service and this guy as asynchronous web service. Okay. And I want to integrate order processing system with card validation system. Okay. I want to establish a communication between order processing system and card validation system. Similarly, I want to establish a communication between order processing system and billing system. Observe the arrow direction. Why I am using a different arrow direction between card validation system and the billing system? Can anyone guess why I used different communication pattern?
Sir, it is asynchronous service, sir.
Synchronous web service, no
Synchronous
need to
service. Yeah, perfect. So card validation system and billing system are two different web services. One is synchronous web service and one is asynchronous web service. These two programs I want to access from a third program, which is order processing system. I mean, order processing system becomes client application with respective to card validation system and billing system. See, in our earlier practice, what we did, we developed a hello world, we developed an addition of two numbers web service, subtraction of two numbers web service, this kind of individual services we developed. But now what I want to do is, I want to develop a requirement. That requirement divided into three parts. Each part of the requirement is one service. Okay, so one is card validation system, second is billing system, and the third one is order processing system. Okay, so all three are just simple web services. There is no change in the concept. All are web services only. Okay, but the question is, when the order processing system communicates with card validation system, observe the communication pattern, and when order processing system is communicating with billing system, observe the communication pattern. Billing system is an asynchronous service. Order processing system is a client of billing system. So order processing system has to take care how to send the input to billing system, how to receive the output from billing system. Both should be initiated by order processing system. But for card validation system, it's a synchronous web service. So order processing system will take care how to send the input. Card validation system will take care how to send the output. Okay, so this is the very high level diagram about our requirement. Okay, so guys, there is one very important note you need to remember. When your partner services, when the target services, or you can say partner services, okay, with respective to order processing system, card validation system and billing system becomes partner services. Okay, when one of your partner is asynchronous service, one of your partner, I mean, with respect to order processing system, one of the partner service is asynchronous service, then this main service must be asynchronous service. This main service must be asynchronous service. You got the point? Suppose my order processing system is communicating with 10 partner services. Out of 10 partner services, 9 partner services are synchronous, 1 is asynchronous. So then order processing system must be asynchronous. At least one partner is asynchronous. Your actual service must be asynchronous service. Are we good? Okay. So now what we are going to implement in these services, we'll see one by one. One by one, we'll discuss about each service and what we are going to implement. But this is the final output I am expecting as a project. Let's assume it is a project. It is a project collection of 3 services we need to develop. How to develop each service and how we can move them to production, that we need to see. Okay. Now, to perform this, I want to work along with Git. For that, what I want to do is, let's assume whatever the SOA application we have, whatever the SOA application we have, let's consider it as existing code to start working with Git repository. Okay, this is our existing code. Now, from this existing code, the new order processing system I want to implement. This is a new implementation we want to do and merge with existing code. Okay, what is our existing code, sir? Let me open the notepad. So our existing code. What is our existing code? It contains one SOA application plus 3 SOA projects. This is my existing code. Okay. Now what I want to do, I want to create a feature. First I want to move this to GitHub. Okay, existing code. I want to keep this in GitHub. Okay, existing code. Whatever existing code you have, keep it in GitHub. Okay, make it as a master branch. I want to treat this as my master branch. Okay, once this master branch is ready, I want to prepare a feature branch. And develop new code that is card validation system. Okay, this way, once the development completed, merge your feature branch into master. Okay, merge your feature branch into master. So now what master contains? Master contains existing code. That existing code is old code plus new code. So now what happened at this point of time? When you merge your feature branch into master, your master contains one SOA application plus 4 SOA services, correct? Earlier three projects we have. Now we have 4 SOA projects. Any question till this point? Any question? Earlier master contains one SOA project plus 3 SOA, one SOA application plus 3 SOA projects. But after you implemented a feature branch with a new service and you merged back to your master, now your master branch updated, which contains one SOA application, 4 SOA projects. Are we good? Any question?
Yes, sir.
Guys.
Clear.
Okay. Now, after this, what I want to do, I want to create a feature branch from master. Okay. Every time we create the feature branch from master only. Okay. When I'm creating a feature branch from master and I created the new service or the new code, I call it as billing system. See, this is the diagram. First, we developed the card validation system, and then I want to develop the billing system. Okay, so if I develop the billing system, okay, and my development completed, testing completed, everything is working good, then what I have to do? Merge feature branch into master. Okay, feature branch into master. Then if you perform this, what is the current state of the master? It will contain one SOA application with 5 SOA projects. Okay, and finally I want to repeat the same process for order processing system as well. order processing system as well. This time I want to develop OPS. Okay, and then this becomes 6 SOA projects. So this is the life cycle I want to implement. Each service I want to implement in a feature branch and then merge it into master. Any questions, sir? Any questions? No?
No, sir.
No? Okay. So now this is what I want to show you. Okay, let's start with the first step. What is the first step? In GitHub, we want to have a repository. Okay, it's very simple, guys. Let me show you the process. What is step number 1? Create GitHub account. Create GitHub account. It's very simple. As I show you some time back, you go to Google and log in into GitHub. You can create a GitHub account like anything. I mean, like it's Gmail or Facebook account you create, right? Like that, you create a new account. Okay, and then step number 2, install Git command line interface in developer's machine. Okay, this one also I have shown you where to download the Git command line utility software and download it, and just simply double click on it and then install the Git command line utility. It is over. Now create repository in GitHub. Create repository in GitHub. Okay, just go to your GitHub login. It's a web accessible application. Okay, here you can see, if you are in the home screen, this is the home screen, you can see an option called create repository. Simply click on this, and then you can give a name to your repository. I want to say it's a repository, sir. It's not a branch. First you need to create the repository. Under repository you can create any number of branches. Okay, I just named it as June 2022 is my repository name. Okay, see, this is a public, right? Public domain. This is a public domain, so your repository must be unique. Okay, and I mean within your account, this is my account, I'm the owner. Within the account I can create multiple repositories. Each repository name should be unique. If it is not unique, I mean it will not allow you to create 2 repositories with same name. That's what the reason. It will give you the validation as well. Anyway, if you see the green checkbox, that means this is a valid repository name. There is no duplicate repository. Okay, within my account, okay, create a new repository in my account. Okay, and then see, guys, this is the public repository or private repository. If you want to go to private repository, you need to take the subscription of paid service. You need to pay the fee. Okay, but I don't want any private repository. I'm going with public repository. Okay, if you want to add any readme file, that's your choice. You can add a readme file. Otherwise it is optional. I suggest you just add a readme file and then click OK. Click create repository button. Okay, just create repository button. See, okay, so there is one more thing. So what it is asking, this will set main as the default branch. This will set main as the default branch. It's the default setting. Okay, I will show you what is this main is. Okay, create repository. Done. That's it. Very simple to create a repository. Now you see, if I go to my home page, this is my home page. If I go to this, so there is one repository in my account. Okay, you can create multiple repositories. You can create second repository, third repository. How many repositories you want, you can create that many. So one repository is enough for me. Let me go inside to this repository. In this repository, see this, guys, this is the branching. So the first branch is called as main branch. Of course, I don't want to go with main branch. What I want to do is I want to go with the master branch. It's your choice. I mean, the naming convention is your choice. You can give any naming convention. Okay, so this guy is calling main branch. Some tools are calling master branch, something like that. Okay, let it be a main branch for now. Okay, and here you can see this main branch contains a file called readme.md. Okay, if you want, you can edit it. You want to keep some content in this file, you can edit it, not an issue. But I don't want to do any changes at this point of time. Let me cancel it. I need to introduce few operations. Okay, so that means, I mean, what I want to say is, in this browser you can edit the files if you really required. Okay, anyway, so this is a main branch. This is a main branch. Now what I want to do, let's go to the developer machine. This is a central repository, right? GitHub is a central repository. Now go to developers machine. This is developers machine. Okay, in developers machine, go to a folder. Just choose a folder. Let me choose a folder in my D drive. I will go to D drive. I create a folder. GitHub. Naming convention is your choice, guys. Any name you can give. What I will do, git repo 2607. I'm just giving some name. Okay, go into this, right click here, and then you need to select git bash here. Done. So now I got a command prompt. In this command prompt, what I need to do, I need to run few commands to connect with the central repository. So the repository is available in the GitHub, right? I want to clone it. Whatever central repository I have, I want to clone it. So this is what we discussed. See, this is the GitHub. We have a repository. With main branch or master branch. Okay, I want to clone it. This is the step I want to do. I want to clone it into my machine. How to perform the cloning, I am showing you. Okay, so what we need to do, first we need to run few commands. Okay, so git, this is the command. You need to configure few properties. What is your username? I mean, you can give your name, nothing else. Okay, I will name it as Santosh. Okay, some username, whoever the user using that repository, trying to use the git command line utility, they can run the command. First, you need to run the command. Okay, and then you can use the second command. Oh, sorry guys. First, we need to. This is the first command you need to run. Missed the order, but this is one-time job, guys. One-time job. Okay. So what I can do, you need to run this command git remote add origin, and you need to provide your repository URL. If you go to GitHub, you can see the repository URL somewhere here. Copy path. What is this path? No, it's not. June 20. Okay, just click on this June 2022 here. I should get the URL.
Sir, click on code, sir. Code.
Where is that?
Right side code is there. Highlighted, green mark, highlighted code. Below, sir.
Correct. Sorry. Thanks. Okay, if you click on this code icon, you can see HTTPS option, SSH option as well. Today I'm not discussing SSH. I will show you how to connect with SSH as well. So we can go to HTTPS. Okay, here this is your repository URL. So what you can do, go to your repository, go to your command and paste the URL. So this is the URL you need to run in your local git command line utility. Paste. So what happened? Not a git repository. What happened? Give me a second, guys.
This conference will now be recorded.
Okay, guys, what I'm doing is I'm using a wrong command. So I don't want to use a remote add command. I want to use git clone. We thought of using git clone, right? That's what our discussion. We want to perform a git clone operation. So I'm using a wrong command. So now use git clone and the endpoint of the git. are the, you can say, URL of your Git repository. This is my URL. This is the URL of my Git repository. So this is the command you need to use. You need to by heart the commands, guys. There are a bunch of commands, around 10 to 20 commands you need to by heart. Okay, and then start using them. Just place the command. Once you place the command, it will clone the repository. It will clone the repository. Okay. Now go to the physical directory and see this directory. Once I perform the clone, see earlier what I created a folder called Git repo 2607. If you open it, it is an empty folder earlier. But now once I clone it, the entire repository downloaded. Entire repository which is in GitHub, it is downloaded. Okay. Suppose if I open this, what our repository contains? Only one file. Our repository contains one file called readme.md. There is nothing else. Readme.md. There is nothing else. See, this is a central repository. This is a GitHub. Our GitHub, my repository contains readme.md. When I clone the repository, I got the same repository folder, June 2022, which contains a readme file. There is nothing. I mean, the entire repository downloaded into my machine. Okay. Now, in your command line interface, Git command line interface, what you can do, you just add your SOA code, whatever SOA code you have, that's what our understanding, right? The next step, what I want to do, up to this, we are done. Create repository in GitHub and then clone repository into developer machine. We are done up to this one. Okay. Now, step number 5, keep existing code into local repository main branch. Of course, guys, we are referring it as master branch. Okay. Keep existing code into your local repository in main branch. Okay. It's very simple. Now go to your JDeveloper. First go to your JDeveloper, close everything, including your SOA application. I hope everybody knows how to close the SOA application. Close SOA application. Then you removed it from your JDeveloper. Now go back to the original location of your SOA code. My SOA code is in C drive. Okay. Let me go to C drive. It's in my C drive, JDeveloper folder, my work, and this is my application. This is my application which contains Hello World, Project 1, Arithmetic Service. Total 3 SOA projects. Okay. Copy this application. Okay. Paste it in your repository. Okay. Copy the application from original location. Paste it in your repository. Now go to Git command line utility. Okay. So guys, if you check the path, we are not in Git repository. See, this is the Git repository path. Git repo 2607. Under that, this is our repository folder, June 2022. In your command prompt, enter into June 2022. Okay. Now observe the difference here. Earlier, it is simply a folder. This is a Git repository folder. It will show you the branch name as well. When you enter into Git repository, it will show you the branch name. This is how you identify whether you are in just a normal folder or in the repository folder. Are we good? So now I am in Git branch. What is the branch name? Main is the branch name. Okay. Here, if I say git status, observe this file is saying there is a folder which is not committed, which is a new one. Okay. I mean, this is not related to the repository. Somebody placed it newly. We placed it, right? We placed it manually. Correct or not? Okay. So now I want to tell the Git repository, yes, I placed it, but I want to consider it. Don't treat it as a private file. Don't treat it as a culprit file. So I want to include it in this repository. Earlier, we have only one file in repository, that is readme.md. But now I want to include a folder which contains collection of subfolders. Each subfolder contains collection of files and subfolders. All these things anyway I want to consider. Okay, for that what you need to do, see guys, at any time if you run this command git status, it will show you the status of your repository. Is it in a good way or not? Are there any existing files? Are there any new files? Are there any modified files? It will show you. Okay, remember this command git status, git space status. Okay. So what are all the commands we are using? So this is the clone command. Okay, first thing is you need to run the clone command, and then you need to run, I will give you the list. Okay, I will give you the list. Here you need to use cd repository name, I mean the repository folder name. This is the second command I ran, right? Sir, when I am using these braces, that means it's a dynamic keyword. You need to change that. So here, in my case, my repository name I provided. In your case, you have to provide your repository name. And then you need to configure these two properties. I already configured in my machine. That's what I did not run it. Okay. So these are one-time commands. One time, if you run these two commands, that's enough. You don't need to run this next time onwards. Okay. And then what I did, I added my code. And I ran a command called git status just to see what is the current status of my Git repository. So what it is saying, there is an untracked file. That means Git is saying this is not my file. Okay, this folder is not mine. This folder not from the central repository. Okay, so what I want to do, I want to tell the Git consider this folder as well. Okay, for that, let's go to git GUI. This is a command. Git GUI. This is a command, gives you a graphical navigation. Let me click enter button. So once you click enter button, you will get a pop-up with all the files, with all the untracked files and all modified files as well. See here, these are all the untracked files we have, untracked files. Okay, unstaged changes. Okay, you can select them. You can select adf config.xml. So these are all not required. See guys, .data files are not required. You no need to include them. These are system generated, and every time they will generate by their own. Okay, you don't need to consider .data folder. I need to consider the JWS file. See the icon corner, you have an icon, just click it. Once you click the file, see that is coming into staged changes. From unstaged to staged changes. And then I will select the project to JPR project 1. Okay, under this SCAINF also not required. SCAINF also system generated files, they are not required. Okay, composite file is required. File list is required. Okay, and then see guys, these are all the different files. See the project 1 arithmetic, right? There are few unwanted files which we really don't want. Suppose this graphic.xml we don't want. Okay, people we want. Go one by one. People we want. Okay, and then diagram file we don't want. Diagram.xml we don't want. SCA log we don't want. Out.xml we don't want. XSD we need. Okay, visitor we need. So this way, all required files I want to select. Just observe. All required files I want to select. JPR I need. Graphic file not required. Hello world is required. Okay, so I mean, if you commit, I mean, if you select all files, then what happened? Nothing happened. These files are not required. I mean, unwanted files we can avoid. Okay, this is not mandatory to select these files. Okay, so what I will do, let me select all the required files and I will give you a simple list. One, response XSD, visital, just simply say, in the pop-up simply say continue. Graphic.xml, XML log, XML JPG, XML out, log, XML JPG. Any other file I missed? Okay. See, these are all the files got selected. Okay, ADF config, JWS is a mandatory file. Project1 JPR, arithmetic JPR, arithmetic service JPR, hello world JPR must be there, right? Hello world JPR. We missed hello world JPR. Hello world JPR. See this? This is a mandatory file. Hello world JPR is selected. What else? This WSDL also required. Make sure required files you should not miss. Anything else I miss? Composite also required. Jar not required. This is not required. File list you can select. Anything? Let me cross check if did I covered everything or not. Okay, so all required files I selected. Just observe here. These are all the files. So one is SO application. It contains an ADF config.xml and JWS. I will tell you, I will talk about this ADF config.xml going forward, but now just select it. And the mandatory file is JWS. At application level, these two are mandatory files. Application level. Each application contains our application contains 3 projects. Project 1, arithmetic service, hello world. Our application contains three project files, 3 projects, and each project, the mandatory files you need to select. What are the mandatory files? XSD, WSDL, composite file, people file. Okay, so these are all the mandatory files. So I selected the mandatory files. Done. So these are all the files I staged. Just simply close it. I will close it. See, I moved them from unstaged location to staged location. Just close it and check the status again. Git status. Once you click Git status, see this, all the green color files are staged files. We staged them, staged. Okay, and the red color files are not staged, and we don't want them. I don't want these files to be in repository. Okay, this is excess data. So simple, what you can do to avoid the confusion, you can go to your application folder, and here whatever you don't want, you can delete it, guys. Delete the .data file. If you go to arithmetic service, you can also delete src. Okay, if you go to arithmetic service folder, you can delete deploy folder. Okay, deploy folder not required. If you go to SOA folder, skyNF not required. That's it. So I'm just trying to clean up my file, my SOA project. Okay, unwanted folders I'm deleting to avoid these files. Excess files are coming, right? Before you stage the files, you can delete, you can clean up your code. Then what happened? Unwanted folders and files will be removed from your repository. Now, if you see, if I click the git status command, see this got decreased. The unwanted files got decreased. Okay. Of course, let me go to git GUI. If you go to git GUI, you can see only 2 unwanted files we want. Even this also you can delete. This also you can delete. Suppose if you go to the folder, what is the path this saying? Arithmetic service, SOA, people, designer. You can delete this designer folder. Okay, hello world, SOA, people, designer. You can delete this. Okay, now what happened? Just rescan. See that files are not at all available in our repository now. Okay, I mean, if you are able to differentiate what file is required, what file is not required, you can simply select the required files. Suppose if you think you are not able to recognize, then I suggest go to your application, deleted all the unwanted folders and files. But these are all mandatory files, guys. Don't delete .adf. Don't delete .adf. In a project, don't delete JPR. Don't delete the SOA folder. Inside SOA folder, people, events, schemas, these are all mandatory folders and a composite file. Okay, don't delete them. Other than this, if you see anything else, you can delete them. Okay, designer. Okay, so what happens? Suppose if we select them, if we stage them, what happened? Nothing will happen. Your repository size will be increased with unwanted files. Okay, why I am saying these are unwanted files? Because whenever you open your application in your JDeveloper, these are all the files will be generated as per that machine. Every developer clones the repository and open the code into their machine, right? Their JDeveloper. Whenever this is opened into JDeveloper, all the files whatever I deleted now are regeneratable files. JDeveloper will regenerate them. So we don't need to keep them in our central repository. It's not part of the code, it's configuration. Okay. Now, anyway, once you are good, go to your Git UI. These are all the staged files. We need to give a commit ID. I want to include them. In my repository. See what it is saying. Your Git is saying these are staged files. These are staged files. Okay. So we need to commit them. Let me do Git UI. I want to give a commit message. This is my first commit. Just give a commit message. Okay, so if you commit, it committed into your local branch. What is your local branch? Main local branch. Okay, so now if you click on if you run the Git status, just observe Git status. See, it is clean. Your workspace is clean. Earlier, it is showing some files in green color, some files in red color. So all these green files are staged files. Now, when you run this Git status, now it is showing it is clean because we committed all the required files and we deleted what we don't want. Clear? We committed all the files, but guys, in the main branch, you have all these files. You have all these files and folders. Okay, but if you go to central repository, it is still in the old state. Main branch, it contains only one file because we added our new code. We added our code in our local repository, not in central repository. We added our code in our local repository, not in central repository. How we can update central repository? We need to perform something called git push. Okay, if you go to the Git GUI, we already committed. There are no files to commit anymore. I just want to do git push. When I do git push, it will ask me this is central repository branch. Which central repository branch you want to update? I want to update my central repository main branch. Just click OK. Then what happened? My local code going to central repository. Is it clear? Everybody?
Yes, sir.
If you go to central repository now, just refresh the screen, you can see updated folders. See, readme is the old file. This is the updated folder. Newly, we pushed into central repository. Okay, now click on this June 22 SOA application. You can see all the mandatory folders and files which you committed, project 1, arithmetic service, everything you can see here. That means you updated your main repository. Okay, now let's assume this is, I'm done. I'm a developer 1, I'm done. Okay, I'm done. I closed my machine. Assume this is a different machine. Everything, I will delete everything. I don't have any copy in my machine anymore. I deleted everything. Okay, I don't want anything in my original folder as well. From original folder also I deleted my application. So now where is my application, sir? Where is my application? I don't have any local copy. My application is available in central GitHub repository. Central GitHub repository. Okay. Now let's assume I'm developer 2. I'm developer 2. Just give me another 5-10 minutes, guys. I will close this. Okay. I'm developer 2. Okay. I want to work on this repository. I want to start doing a new code changes. I want to start working on card validation system. So what I need to do, first I need to clone the repository. So what we need to do, first create a folder. Under this, go to git bash, and here you need to perform a git clone. You need to perform git clone. Okay. Once you perform git clone, see this, I want to perform git clone. Once I perform git clone, what happened? The total repository cloned. Okay. Now what I need to do, what is the second command? cd repository name. Then I entered into my repository. Which branch of repository? Main branch of repository. So guys, I want to create another branch. I want to create another branch, not just main branch. I want to create another branch. So what happened? This is the command you need to use. Git branch feature / card validation system branch. I'm creating a feature branch with this naming convention. This is a user-defined keyword only. Feature / CVS is a user-defined keyword only. You can give ABC as well. No need to use feature / CVS. Instead of feature / CVS, I can also use a naming convention called ABC. Not an issue. But it is an industry standard to use the proper naming convention. So I want to create a branch. It is copy of main branch. See, currently I am in main branch. But I want to create a duplicate copy of main branch. For this, you need to run this command. Git branch feature / CSV. Done. So now what happened? We have two branches. Git branch. See, if you run this command, git branch, it will show you the branches available in your local repository. So how many branches we have in our local repository? Come on, guys. How many branches we have in our local repository? 2 branches. One is main branch. Another is CSV. Okay, 2 branches. So how to create a branch? This is the command to create a branch. Git branch, name of the branch. Okay, any question? This is the command you need to run. Git branch, name of the branch. Okay, now, and how to see list of branches? If you say git branch, this is the command. If you run it, it will show you all the available branches. Okay, in your local repository. See, in my local repository, I have 2 branches. But if you go to central repository, this is the place you can see the branches. So here it is showing only 1 branch. It's because I created the new branch in my local repository, not in the central repository. Okay. Suppose if I want to move this branch, the new branch, I want to move it into central repository, what we can do, first we need to enter into the branch, git checkout feature / CSV. If you do this command, what happened? You will enter into the branch. FEATURE CVS. Oh, I created wrong name, CVS. Okay, anyway, let me use the proper name. If you use the wrong name, you cannot use this. Okay, CVS. Now observe, from main branch, I checked out into a new branch. feature/CVS. And here git GUI, just go to git GUI and say push. If you say push, this will be reflected. This will be reflected into your server. Just push. Whatever local changes you made, you want the local changes into central repository, you need to perform push operation. Done. Now go to your central repository, refresh the screen, and now you can see here main branch feature/CVS. Any question? So you understand how we can create a feature branch, in our local repository with a command. It's a very simple command. If you run git branch and your branch name, you can create a new branch. If you do git branch, this command will list out all the branches in your local repository. And then if you use git checkout and name of your branch, what happened? You will enter into that branch. Okay. And then you can push the changes. Any changes you want to push into central repository, go to git GUI, and there you can see commit command, commit button, and there you can see push button. Okay. Any questions? Any questions till now? From anyone?
No, sir.
Okay. So once you are done with this, now I have my local repository, right? So what I will do from my JDeveloper, I will open the application which is in the local repository, not in my earlier folder. No more I'm going to use my earlier folder. Okay. So my repository is in D drive. Let me go to D drive, developer 2, June 2022, and this is the application. I need to browse the JWS file. Okay. See, I got my JWS file and I got all the projects. Any questions till now? Okay, so complete your practice till this point. Okay, fine. I need to tell you one more thing as well. Sorry, guys. So we saw how to create a new branch. In the command line utility, correct? So we can also create a new branch in the central repository as well. So here, if you see, I'm in main branch. From this main branch, the current branch is main branch, okay? I want to create a new feature branch, feature/test1. Okay, once I click this, see, there is an option. I got an option, create feature/test1 from main. Okay, I want to create a new branch here. You need to select this option. Just click on it. Then what happened? Now you have 3 branches, main branch, CVS branch, test1 branch in your central repository. You can see 3 branches. But in your local repository, you still see 2 branches only. Git branch. See, it is still showing you 2 branches because this local guy don't know what happened at central repository. So what we need to do, we need to run a command, git fetch. If you run the command, it will update the local copy. And now what happened? It fetched the branch. See here, it fetched the branch. When I click on it, it get the branch. We got the feature/test1 branch. Okay, let me git checkout feature/test1. Anything wrong? FEATURE. Spelling mistake. FEATURE. Why it is taking time just to move the cursor? FEATURE. Okay, right spelling. Done. I switched out. I check out, and of course I can see the branches now. All the branches. Okay, so you made any change in your local repository. To bring the change into central repository, you need to perform push operation. If you made some changes in central repository and that you need to bring into your local copy, you need to perform git fetch. Are we good, sir? So few commands I am showing you today. That's it. Not every command. There are so hundreds of commands are there. How to play with Git. Okay. Anyway, so these are all the few commands we use it today. You do some practice today. In the next session, we actually works with the SOA service in the combination of Git. Okay. So you complete everything what I did today. Complete everything. From tomorrow, it becomes very easy for you. Okay. Let me stop the recording.